Hello, everybody. Seems like we are starting now. So thank you for coming. Thank you for your time. I'll do a short presentation. We are 3 people from Hitachi Energy today. We'll talk about the way to sustainable future in energy industry through the supply chain. And today I have with me my colleague Syed Kianfar, the areas marketing and sales manager for high voltage products, and Firuz Aziz, who's the marketing and sales manager for transformers. My name is Amer. I work as the global marketing and sales manager for Hitachi Energy Consulting. And we'll talk about both about the what it actually means, the sustainability in the supply chain, how it's measured, how it's reported, and then my colleagues will also talk about sustainable products and solutions from Hitachi Energy to show examples of how we're helping our customers towards this CO2-free future. So just to set the stage a little bit, the IPCC report, which has basically outlined a couple of scenarios for future temperature increase and its effect on the climate and our world, is something that's well known, so I won't go into details, and I know that sometimes it's contested, whether it's correct or not, but we can without doubt say that we humans have and are affecting the climate today. And looking at, there are basically 2 scenarios, 2 alternatives. The report is wrong and we do nothing. Fine, the report is right and we do nothing. That cost is much higher than we doing something. So there's basically, it shouldn't be a choice, and I think that's well established now. Already now, 24% of the global landmass is affected by degradation. And I mean, we have the fastest rates of sea level rise in the last 3,000 years, highest CO2 concentration in the last 2 million years. So it's very hard to say that nothing's happening. It's normal. It's not normal, right? And energy sector is the key contributor to climate change because it counts to 2/3 of the global greenhouse gas emission. So we have a job to do, everyone that are working in this business. So to achieve this carbon neutral energy future, we need to transform the energy system in unprecedented level. And it's happening now already, and there are 3 major forces or 3 major areas where this is happening in the same way, in the same time. We have the electrification industry, sorry, just give me a sec here. We have the electrification industry, so basically they are looking to double their electricity consumption. We have more buildings, of course, growing. We have electrification of transport, so basically load is increasing, right? At the same time, we are projecting, although it's being projected that 80% of future energy generation is going to come from renewables instead of fossil generation, which brings with it, its own challenges, as we all know, right? Which also implies that we will need to transfer 3 times more energy in our grid by 2050 than we're doing now. So there are 3 basically key technologies that enable energy transition, which are foundation for system of systems. And these are sustainable product solutions, power electronics due to its flexibility and applicability, and digital technology services. So a little bit about where we, Hitachi Energy, are currently, where we see, based on the report that we released, where we see that we are active and where we are contributing today. It's in generation by enabling renewable energy, right? And integration of renewable energy in the grid. Transmission and distribution with infrastructure that helps increase the capacity and host all the new generation that's being built. In consumption, by enabling hydrogen production, for example, data center interconnection, etc. And then basically we are serving all those markets. But also the battlefields where we see that we are active in is basically transforming through low carbon technologies. So we are working on our own products, making them less carbon intensive, so that we help our customers, as you will see later, scope 3 emissions. As I said, supporting transition to renewable energy, expanding and strengthening transmission distribution grid, and as I said, supporting enabling industry decarbonization through electrification and enabling alternative energy vectors. So we are trying to do our best to support this transition in as many segments as possible. So what is the energy landscape? What does it actually comprise of? And as you'll see, it's usually we talk about carbon footprint, right? And we talk about energy efficiency. And there's a reason why these two are mostly mentioned. It's due to the structure reporting today, scope 1, scope 2, scope 3. But there's much more to it, right? We have the baseline and roadmap. We have LCA standardization, and LCA stands for life cycle assessments, where basically you do a carbon footprint assessment calculation of our product's whole life cycle. EPD stands for an environmental product declaration, which is a LCA but certified by third party. And DPP is the digital product passport. And this has already been tested in our PGHV, one of our PGHV products. So there's a lot of things that you can include in the sustainability landscape. But one that I really wanna emphasize as really important is sustainability data lake. This does not exist today, and this is the vision for the future. Because when we are talking about sustainability, if that's GHG footprint, if that's CO2, if it's any type of sustainability, of course you need to measure it. You need to measure it before, you need to do some actions, and measure after, and you need to track it in real time to see what are the right actions to be taken. And there's in this this cliche, but it is a cliche for a reason. What gets measured gets managed. Today, one of the main issues is data availability about the carbon life cycle, carbon footprint of products. And the dream or the vision for the future is to have a sustainability data lake that can be accessed by users, by OEMs, by anyone that needs to have the access, and because that would be the ultimate source of truth, where you can basically calculate the LCA footprint for a system throughout its whole life cycle, not only of one OEM, not only of one utility, but across the whole value chain. So hopefully we'll get there eventually, right? So a little bit about the greenhouse protocol. And this is something that was developed by WRI, World Resource Institute, and the World Business Council for Sustainable Development. And I'm sure that all of you have seen or heard about scope 1, scope 2, scope 3. And here I'll just try to shortly explain a little bit how this relates to a company's operation. Because now most of the businesses are looking to reduce their environmental footprint, and they also need to report it. And one of the most significant ways to reduce the GHG or your environmental footprint is to reduce your carbon footprint, and this starts with monitoring. So you can see here that we have scope 3, scope 1, scope 2, and scope 3 again, but it's also divided by upstream activities, reporting company activities, and then downstream activities. Upstream, that is scope 3, is everything except energy that you purchase as a user, including your business travel, your own people's business travel. But if you buy capital goods, if you buy fuel, if you buy transport distribution, etc., etc., everything is included in Scope 3. So, and that includes, in case when we are talking about products, the product you buy is Scope 3, and all the carbon captured throughout the whole life cycle of that product is accounted for your Scope 3, right? Then we go to Scope 1 for you as a reporting company. It's basically everything you have control of. Your facilities, what's their carbon footprint in their operation, and your vehicles. And today this is what is mostly being reported. Scope 1, and that's mostly being focused by companies, and I think that's going to change going forward. Scope 2 is everything you need to purchase to run your production. So basically energy, cooling, heating, and steam. So if you are using products, raw material, etc., that's Scope 3. You have your facilities that might have losses, etc., or that might, you have company vehicles that also have carbon footprint in usage, and then all the energy you use basically to convert any type of raw material or some kind of product to something that you're going to sell is your Scope 2. And then again, Scope 3 are all downstream activities, basically how you distribute your products or services, how they are being used by your customer, end of life, leased facilities, etc., etc. So if you think about this, that at each end of this graph, there's someone else, some other company that's being either buyer or seller. You see why this is circular, and why we that are in the energy business, because energy is used for everything, are important in this kind of circular sustainability economy. Because we as Hitachi Energy manufacturing products that are being used for electricity transmission, for example, we also buy energy and a product which is not always easy to address for, a product sold in, for example, a country where they have 100% renewable versus a country where 100% coal is used, will have vastly different Scope 3 impact, because that's also measured on your downstream activities. So an action would be, okay, sell to those countries where they have renewable energy, but that's not a solution, right? You need to help everyone improve. So as I said, it's not always straightforward. If we take a case study and an example here, we have a utility, and this is a real example from a utility that we built a HVDC converter station in Europe for offshore wind connection. And we basically measured or identified a share of Scope 1, Scope 3, Scope 2, and Scope 3 emissions, or GHG. And we can see that, okay, Scope 1, mostly SF6 leakages. Scope 2, equipment losses. So basically, since this is HVDC converter stations, we are talking about electrical losses in transmission. And then Scope 3 is embodied carbon. That's all the equipment, all the concrete, everything that they bought to build the converter station, to put it in place in operation. And that accounts for 68% of, if I've seen this right, 68% of their carbon footprint, right? So if we look a little bit about on example what we as a company and other companies that are in business can do, this is basically our actions, what we are working on today to reduce our carbon footprint for our products, and basically addressing Scope 3 of our customers. It's improving how we source, and that's again our Scope 3, right? Transportation of raw material to us to make it less carbon intensive. PPAs for clean energy, for energy that we use. Improving technology that's going to be iconic and lower losses, for example. And those lower losses will affect your customer Scope 2, and then improve how we transport to our customers. And then if you look at how this affects this utility on its end, and you'll see that this is color-coded. So the white ones are corresponding, black ones corresponding, and red ones corresponding. Okay, that's much better sound. So benefits on transportation, distribution on Scope 3 or from the customer on their upstream, sourcing. We help their sourcing, and we help their reduction of losses because we design and sell better products which are more efficient. And this affects their scope 2, and then ecological leakages, which affects their scope 1. So this basically shows that we all need to do an effort, right? No one can do it alone, and this is also important. It also outlines why this data lake or the reporting is important, because it's accounting for a whole circular economy of this can be pretty complex because there's so many interdependencies. So, but there are digital tools that help a lot, and I will talk about this a little bit later. For that matter, we'll have a Q&A after we all are done, so feel free to ask questions afterwards. So, let me see here. Sorry. So, okay, just give me a sec, please. I'm having some technical issues here. So how do we start this journey together, right? And I'm talking a little bit about what we do today and how we can help our customers work with this. Step is 1, calculate. Calculate where you are today. Calculate your whatever you have planned to do. So basically create a baseline measure. Then implement, which is basically when it comes to products, we are working on producing and having better products from a CO2 point of view, and then track report. When you have your facility in place, you wanna basically be able to track its CO2 footprint, identify hotspots, and then report them, and also based on what you see, take actions to reduce them. So if we go to the part of calculate, I mentioned LCA before, and we have this within the group that I work, ecological consulting practice, which basically focuses on 2 things. One is LCA service, helping customers with basically addressing each customer unique environmental performance needs. And the goal and the purpose is to identify each customer's sustainability related performance and initiatives and improve the overall carbon footprint. So it's about developing strategy, advising, what are the right actions to be taken, when, etc., but also showing proof for that. So the LCA is one of the main tools for that, basically because it measures baselines. You get a baseline where you are now. What are the hotspots that needs to be addressed? And when I say hotspots, the hotspots are part of your operation and your products, your scope 1, 2, 3, that are causing the biggest footprint, right? Create decarbonization roadmap, structure program and incentives, and communicate commitment, right? Then also, when we talk about consulting services, you can, there are certain kind of legacy traditional services that any company offers, but then there are also those that can be addressing certain points of the scope 1 and scope 2 of a customer operation. And that's how do we improve availability, predictability of operation, and energy productivity, because all those 3 aspects will positively impact scope 1 and scope 2. Anything that reduces losses, anything that improves efficiency, and efficiency is not only let's turn off a compressor, when it's not being used. It's also about how do you maximize output of a production for a certain input of energy, right? That's another example. How do you avoid, if we talk about industry, how do you avoid outages for industry, because that causes delays, it causes maybe increased carbon footprint when you need to start up again, etc., etc. So LCA, as I said, that's the assessing the impact on the environment. So it quantifies the environmental impact on the product or a system from cradle to grave. So basically includes the whole life cycle. It includes both raw material extraction and production. It includes service, end of life, supply chain, use of products over the lifespan, transports, and own operations. So it's basically encompassing comprehensive structure, which then can be, if needed, a third-party certified, as I said, EPD that we mentioned before. I should probably switch this. So this is what I was talking about. Sorry for that. And then I'll jump here to track and report, right? Because my colleagues will talk about implement, if you remember those 3 steps. And we are basically, if you look at the here, right, we have plan, design, build, operate, maintain, and then end of life. So if we split it in 2 parts here, we have BIM and Identic. So this is a digital, basically, design tool, which is building information modeling, and that's what the abbreviation stands for. And it's our basically design process to identify improvements in the design phase already, and then may ensure that those are implemented when you build the facility that are more sustainable. So basically identify sustainability improvements in the design phase. Then when it's built, all these data can be migrated to Identic, which is basically a digital tool. You can see a screenshot here, which shows both the embodied carbon, and what you can see here, for example, there are hotspots, as we mentioned before. Red ones are transformers, yellow are vaults, and the green is the rest of the equipment. So it's and this is basically a real-time digital tool that you can connect to your facility, which means that you can also track and report real-time data. So depending on the usage, for example, in this case, power flow, how much it's used, how much it's not used, you get basically a real-time tracking and reporting of carbon footprint that you can use for reporting to the regulators. And then we have EcoSpace, which is another tool, also digital tool, which is also addressing and measuring all the carbon footprint related to maintenance service. So service related to maintenance over the whole lifetime of the product. So basically accounting for everything that you or your service provider does on this facility throughout its whole lifetime, including transports, including any type of equipment replacement, etc., etc. So that's basically that's the infrastructure and the environment we have put in place now, and there are different solutions, right? But this is the basic structure that needs to be in place to be able to measure and to track and report your CO2 footprint in the way that is mandated by the GHG protocol that I showed before. So now I would like to invite my colleague, Saeed. We'll talk about implementation. Okay, I forgot one slide. Sorry for that. Sorry, Saeed. My bad. So this is a little bit about the challenge here also that we see. And as we said before, if you remember the slide where I was showing the carbon footprint based on scope 1, scope 2, scope 3, right? And we show that scope 3 is the biggest one. If we then derive from what we derive from that is that the challenge and the biggest impact will be from impacting scope 3. So basically companies impacting their supply chain side. So if we take the example of this carbon of this HVDC substation or HVDC converter station, we can see the embodied carbon. So what's all the carbon footprint that comes with building that facility, and what's the division, right? And we can see here that 50% is concrete. And then we probably have 25% steel, copper, aluminum, lubricants, SF6, and then rest of the materials. And all these are important, but it also shows that each and every company needs to work with the whole supply chain to see how they can reduce their scope 3. I know that concrete is pretty carbon intensive, but it's also about pushing, reducing the transport, pushing concrete production companies to improve their processes, etc., etc. And same goes when it comes to all the metals that can be significantly reduced by up to 40% of embodied carbon footprint can be reduced by recycling of metals. If we recycle 50% of metals, that will reduce the copper, steel, aluminum by 40% of the total embodied carbon. So there are ways to do this if we want. So let's switch over to implement econic solutions, and we'll start with my colleague Said.
It's okay, yeah? Very good. Thank you, Amer. Let's start. Okay, my name is Said Kamfer. I'm in charge of high voltage equipment in Hitachi Energy, based in Dubai, UAE. And a couple of sentences about myself. I joined ABB like 2000, and I work in different discipline, medium voltage, then front-end sales. I work a little bit on grid integration, and then finally I moved to HV, and since that time I'm taking care of the region for the HV products. In this next couple of minutes, we talked about our econic solution. Amer talked about a couple of items which I want to start from there. CO2 footprint, and then SF6, life cycle, total life cycle assessment. So in my presentation, I want to link those terminology to our econic product, and to see how we in Hitachi Energy like doing this mission toward a sustainable energy future for all. First of all, about our HV product. The reason which I'm talking about this HV product, to see where we are starting from. In fact, we start from 1968, before that 1957, Westinghouse, the first GIS. We had the first GIS, and that GIS, that we used, for the first time, we used SF6. SF6, the gas which was the best gas by that time. With a fully stable gas with a good dielectric strength, very good performance when it's going to the arc extinguishing, and a stabilized gas. And we use it a lot, then in all sort of high voltage equipment, we and our other OEMs, they use this SF6. And moving forward, we had like GIS up to 800 kV. Then we use it in our lifetime breakers, lifetime LTA breaker, lifetime breakers. And then in 2013, we had our first econic for the LTA. And in that, for 72.5 kV. Then we had also GCB. Within GCB, again, we are using SF6. Because, again, SF6 is a very good gas when it's come to the electric characteristics and also arc extinguishing. And very stable gas. Then moving forward, GIS 1100 kV, hybrid solution again, and then econic LTA 145. We changed the name after that to LTA. And again, then econic high voltage portfolio start on 2021, and the first eco-efficient 420 kV, which we introduced to market, was in 2022. And but before that, as I said, Hitachi Energy, like all other OEMs, we are using this SF6 gas in our switchgear. And it was our hero for the insulation. Very good gas, and the old discussion which we had so far till maybe 10 years ago, the only case with the CO2 which was discussed, whether it's a poisonous gas, what is the effect, whether it is create any problem for us if we inhale it, what will happen, and there was some discussion like that. But later on, when there was some more study about that, we found that now we and together with other OEMs, we are generating or producing a lot of equipment with the SF6. Although this SF6 gas is inside the switchgear, and we are not releasing to the air, but we know that this is some leakage, and as per standard, the allowable leak is 0.1% per annum. And this leakage is the leakage which go to the atmosphere is not only that 0.1% per annum. During the manufacturing, or when we will do the first gas filling, or the gas cylinder of the SF6, when we will transport it from one point to another point, the gas cylinder will stay in some places for a while, and then there might be some leakage from those SF6 cylinder. Or during the maintenance, if there is any leakage in the SF6, or there is another phenomenon which is called permeation. In permeation, if I want to make it a little bit more simpler, the SF6 gas, when you will receive the GIS from any OEM, doesn't matter, Hitachi Energy or other OEM, when you receive any switchgear from any OEM, you will do the FAT in the factory, and then you will check the pressure of the gas, and you will check the leakage. Everything is fine. But after 5 years, you will see that the pressure is reduced a little bit. Everything is fine, but why? This is to do with a phenomenon which is called permeation. The molecule of the SF6, after a while, it will go inside the molecule of the ceiling and also the other part, and day by day, month by month, it will go inside. Then when it will be saturated, it will go, and there will be some small, very small leakage to the outside, maybe after 5 years. So this is something which is unavoidable in any way. There is some leakage. Whether I want or not, there is this leakage available. We came with some super sealed material. We changed the rubber and then said that, okay, we use some rubbers. Nowadays, we use some rubber in our SF6 that this permeation is very low, and the amount of the leakage is very low. This permeation, if I want to make it very simple, like if you put some clothes in the water, some fabric in the water, and leave it for a while, after a while you will see that the water will come up, and you will see the other side of this fabric without of this glass of water is getting wet also. Permeation is something like that. But it will take during the months and years. And as I said, we came with some solution a couple of years ago, super sealed. I used the sealing, changed the sealing, and also use another flange around the another top flange around the connection point. But again, we can reduce this leakage. What about maintenance? What about gas filling? What about SF6 gas cylinder? All of these things will contribute to the SF6 leakage. And then, why SF6? What's the problem with SF6? I think most of you don't know about this. But why we are talking about SF6, and we will make it a relation to between SF6 and CO2. The reason is very simple. We are talking about one terminology, which is global warming potential, GWP. And the amount of the heat which the molecule of CO2 will absorb and contribute to the warming, they consider CO2 as a base, which is 1, and then SF6 if they want to have the equivalent effect of SF6 on the warming of the environment warming effect of that, its GWP of SF6 is 23,500. What does it mean? It means that the leakage of 1 mole of SF6, the effect of leakage of 1 mole of SF6 equal to the having 23,500 mole of CO2. This is the reason that we are talking why we have to reduce SF6. And then another problem which we have with SF6, as I said in the beginning, is very stable gas. It will not go to any chemical reaction. It is very stable gas, and it will stay in the atmosphere for 1,000 years. 1,000 years is a lifetime of SF6. So you have the gas, which with the global warming potential of 23,500, and it will stay in the atmosphere for 1,000 years. So this is the reason that we all working toward reducing of SF6. And as of now, the amount of SF6 in the atmosphere is about 10 parts per trillion. Might be not that much, but looking at the GWP 23,500, that is a lot. That's a lot. So this is the reason that we came up with a solution, iconic solution. Then how we have to make this iconic solution? We have a big history and the experience with SF6. We said, let's build on the same SF6 technology. We know about interruption technology, how is this interruption? And then let's introduce a gas which have more or less the same characteristics of the SF6, like should be no toxic gas, ozone friendly, with a good dielectric characteristics, could be used for the arc extinguishing, and then low boiling point, not flammable. And all these things, we came up with a gas mixture, which we can use for this insulation. And that, when it comes to the solution, how this solution should be presented. The case is that why we use SF6? We use SF6 to have a compact switchgear. If we always talked about the comparison between one GIS substation and one AIS substation. We said that if we have the same 400 kV, for example, with 15 bays of 400 kV GIS, if we have the same one in AIS, we may need, for example, just if I'm not sure if I'm right or not, maybe 10 times more space we may need. And then we need maybe 5 times more concrete and other things. This is the reason that we use SF6 to have a compact solution. So then our new solution also should be compact. With SF6, we have a scalability. What does it mean? We can use this SF6 in medium voltage. In medium voltage, they are using SF6. Like our colleagues in ABB, they are using HD4 breaker, medium voltage. Then we are using from transmission, sub-transmission level up to transmission and also extra transmission, 1100 kV. So it's fully scalable. So 2 things, scalable, and then it has to be reliable gas, and then it has to be compact, the new solution, as compact as we have our existing solution. So this is the 3 main characteristics of the new solution. Compactable, same size, scalable, and reliable. And on top of that, I talk about all these like characteristics of that gas, like non-toxic, non-flammable, and like low boiling point, and so on. Now, here is about our solution. When we are using this gas mixture, we introduced the solution to the market. And this is here you can see our roadmap. In this roadmap, we have 4 categories of the product. The first line talking about live tank breakers. And in this category, we are using one type of gas mixture, which is only O2 and CO2. And then the other one, dead tank breaker, PAS, and gas-isolated switchgear, they are all working based on the concept of metal enclosed breaker, MEB. And in that one also we have another mixture. The second last line is a gas-insulated line. Why gas-insulated line? Is it that much important? Yes, especially in the 400 kV, in many substations, we might have the kilometers of the GIB. As an average, in normal 400 kV substation, we have something like 40 meter of GIB per bay. So 40 meter you consider is a normal case, but 40 meter you consider in the substation, like with 20, 25 bays, it will be around 1 kilometer. In some project, I have came across that they are using up to 10 kilometers of GIB. So then GIB also is important. We have to use the same gas, which is econic gas here. And the last one is retrofill. What is retrofill? The old solution on top, they are talking about new product. The product is completely new. So when you want to buy a switchgear of 132 kV, you buy a new switchgear of 132 kV, and you install it. And the same for 400 kV, the same for LTA, live tank breaker. But the last one, we are talking about using the existing GIB and replace the SFC gas with the econic gas. What we will do, we'll evacuate the gas which is inside that GIB and change the flanges and change the gas gauges, and then we'll fill it with the new gas. New gas also is a econic gas. It's very important here that from the life cycle point of view, we are using the same material. Again, what Amer said, I want to connect to that one. Life cycle assessment, whole life cycle assessment of any product is not only the duration that this product is with you. It's from the beginning when we will go for example, extraction of the copper and the steel. Then we will go to the supply chain. Then it's our factory. We will produce. Then we'll do the transportation, and then it will come to your site. After that is like lifetime with you. Then after that is like recycling, another one. So when we are talking about life cycle assessment, we are talking about the full chain from cart to cradle. So as I said, we have these sort of products here, and with this product, all below the green part is available, and the one which is below the gray part is some of them 2024 already available, like 550 kV breaker. We have already launched it in Sigre a couple of weeks ago, and also 550 GIB. Okay, so as I said, we have a different mixture of gas in the lifetime breaker and in the MEB, metal enclosed breakers. Here we are using CO2 plus O2 in the LTB, and in the other one we are using CO2 plus O2 plus C4FN. You make question that, okay, again we are using CO2, but this CO2 compared to that SF6 which was there, that one had 23,500 more times effect on the global warming. GWP of that SF6, the same amount of SF6 which was using in there, because we are using our new solution is having the exactly same footprint. So practically the amount of the gas which we are using here is more or less the same. So effect of that solution from the leakage to the old solution to this one on the global warming, the old solution to the new one is 23,500 more. And more or less the same for the other solution. A little bit about some comparison. You know, earlier we had SF6, normal SF6, which most of you do have in your installment in your substation. And now we are introducing CO2, O2 and C4FN gas mixture, and some other OEMs, they are using air plus vacuum. Although in the vacuum, we can say that there is no gas, and the vacuum by itself has GWP of 0, but the fact is that the vacuum, because of the technology is new, and then not new, but is not developed to that much, to that voltage level, the product compared to our product is bigger. Therefore, from the life cycle, whole life cycle assessment, the CO2, equivalent CO2 footprint for the manufacturing point of view definitely is higher. The part which is related to the gas leakage is a dark green, which contribution of that one to the whole CO2 footprint is nearly maybe a couple of percentage. But the fact is that when we are talking about air and vacuum, the product by itself is bigger, almost 50% bigger. Yeah, here in this photo you can see, if we compare to these two substations, just as a typical, although this solution might not be available, the blue one, but the green one, when we talk about the size of the blue one is after almost 50% more. Then the problem is here is that we need more material. We need to spend more for the transportation from the production of this product. We have to produce more CO2, and everything from the production point of view till it will reach to your site come from the CO2 footprint is higher than our solution. And the important thing is that when I'm talking about econic solution, our solution is compact and scalable, as I said, and we can do the extension. Suppose you have in your substation, you have 10 bays, 20 bays of, for example, GIS 420 kV. You consider a space for 2 more bays. Now you want to have these 2 more bays, which you have considered some space based on SF6. 2 more bays, you want to try the econic solution. That's fine. We can do it exactly in the same footprint. We can extend your substation by 2 more bays, and we need the same amount of space which you have already considered during the design stage 10 years ago for this substation, and we don't need more space. And when we are talking about extension, we just need the same space as the existing SF6 solution, and we can easily extend our old solution SF6 to the new solution of SF6-3. Here is our 420 kV. When it comes to the electrical characteristics, we are having the same electrical characteristic of the old SF6. Talking about short circuit, talking about the rated current and everything, we can have indoor, outdoor. So all is the same. So it is one-to-one, more or less one-to-one replacement. So, and we have this product available already installed in many utilities. And short circuit 63 kiloamp, 3 seconds. And as I said here, we have the solution which is we have available at the moment, and the solution which is under development. You can see we have 70 kV, 145 kV. When we are talking about the GIS, we have 145, we have 420, 550, but we don't have 245. We are sure that is also available, but it's all about the market demand. You know, we start with the 420 because there is a massive demand in US, and we had a good success story there. Then we had 132 kV because there are a lot of these 132 kV demand in the market in subtransmission. After that, some of the market like China, they are 550 kV. Then we develop 550. The requirement of 220 kV or 245 kV is not that much as others. And you know, for these each production, each voltage level, we have to do all R&D. We have to pass all gates 1, 2, 3, 4 up to gate 5, and it will take time. So this is the reason that we doing like that. But the important is that is scalable. We have 145 kV, we have 550. So definitely 245 kV also is achievable. Nothing but we need some time, and then due to the market demand, we are doing like this. And when we are talking about the gas handling, for this solution also same as SF6, exactly same as SF6. The only thing is that now we have the barcodes when we want to like fill in the gas. The machine from the supplier, they come and scan the barcodes, and then they will fill the gas, and they make the mixture exactly with the bottle of the CO2, O2, and C4F9, which they have it, and they mix mixture, and then refill it, and then we have device like leak detector, we have analyzer, and we have monitoring, and same on. We have the same from the operation point of view, from the gas handling point of view, we have the same concept, and the product, everything is available. The gas also is available. It's the patent is available to the market, and there are many manufacturers around the globe who are making this gas. And last but not the least, our references. 1,100 iconic unit worldwide. It means the all voltage level, LTA or the tank breaker, based on the MEB, or even a retrofit solution. We had retrofit solution in the national grid of UK. We sold many dead tank breaker to US. In Europe, we are there. In Africa, South Africa, we had many LTA. In China and in Australia and New Zealand. The thing is that we need the support of utilities. Those who will also prepare the technical specification. At the moment, we cannot, due to the high cost, the price is not at the same level of SF6, because there are huge R&D investment behind that. But since in the utilities, especially in the Europe, not the utility, in fact, the government, they put a lot of taxation on the using of the SF6. So for many of them, they are thinking about new project to go for the SF6 free, but also the existing one. They do prefer to change it to SF6 free in order to avoid from big taxation. And like the same way I said that in national grid of UK, in order to avoid from that big taxation, there was a couple of kilometers of GIB. We changed it, and they used the iconic gas. And as I said, more than 15 kilometers of iconic gas. And you have seen in the first slide, iconic is not something new, but we have seen the demand nowadays in the market when the utility, the government came with the new regulation, with the new taxation on the usage of the SF6 and all these events which we had about the global warming. The last one was in UAE, I think, last year. Yeah, and then we are having this product in almost 26 countries. So I think by this slide, I'm done, and I will hand over to my colleague Firuz for the transformer. Thank you very much.
Good morning, all. Thanks, Syed. So, my name is Firoz. I'm the Sales and Marketing Manager from the Transformer Business Units of Hitachi Energy. I'm also based in Dubai. So, I would also, would like to talk about how Econics and which is connected with transformers. So, Hitachi Energy's Econic portfolio basically is a step towards supporting the journey of international sustainability goals. So it's not only a product, it's a journey, or it's a step towards to achieve the sustainability goals. So we know that this energy world is moving at a high pace, and there is a paradigm shift of power industry being operated, and how this will operate in the future. So I just would like to discuss on how Econics is playing an important part in this journey, and how we, Hitachi Energy, are committed to contribute towards the United Nations Sustainability Development Goals. Yeah. So when we see the power network today, right from the generation mix to the transmission to distribution and ultimately to the consumption end, approximately 5% of total, global electricity is lost as transformer losses, which is equal to approximately 1 gigaton of, carbon dioxide equivalent. Though the transformers, it's a high efficient equipment. When we talk about the efficiency, it's maybe more than 97 to 99% of efficiency product. We need to understand that the transformer is a critical item in the energy supply network, and there are fundamentally everywhere in the network, and at least 4 to 5 transformers are required before the power reaches to the consumers. So, and this place which we can address to reduce the impact. So, when we talk about Hitachi Energy's sustainable transformer solution, that is Econic, there are 4 fundamental pillars which are supporting the international sustainability goals. Decarbonization, then the safety, protecting ecosystem, then the responsible use of the resources. So when we talk about decarbonization, of course, it's related to the greenhouse gas consideration, then the safety, good health and well-being, protecting ecosystem, life on land and below water, and responsible use of resources, of course, the material and the energy consumption. Again, decarbonization. So quantifial of CO2 emission is required for the products. So complete the processing cycle needs to be evaluated, like whether the product is manufactured with fossil-free electricity, improvement in energy efficiency, compared to applicable regulations with improvement in losses, from material usage, which can quantify sustainability benefits, usage of biodegradable fluids and recycling, of course, the waste disposable impact. Which means, the use of material, when we talk about the use of material from the cradle to the grave, and the impact of each stage to be evaluated properly. Also need to analyze the suppliers. They have a good social track records and contribution towards sustainability goals. So, carbon footprints and transformer losses, when we all can see how the generation mix is changing and will be different in the future. There are transformers in operations probably more than 30 years, 40 years. The life of transformers is talking about probably more than 30 years, of course. So what we are designing today will be there for there for many years. So it's important to consider the most realistic energy mix in projects planning and evaluation. Therefore, materials, whatever we are using it for the production become equally important and can be improved by fossil-free energy during manufacturing process. So, besides the reducing environmental impact, we also need to see additional safety part of with our products. So we have a technology that is T-expand. This is a rupture-resistant tank which will mitigate the significant insulation spills and fire or explosion in case of any internal failures. This has been proven, proven by full-scale testing, and multiple units are already delivered to different regions. So the next one, apart from this, combining of dry bushing, a layer of safety for the products. Since bushings are oil-free, it doesn't have any oil leakage issues or any explosion issues. This will also reduce the maintenance effort since there is no oil. The other one is noise. That is also concerns at the moment because in increasing the urbanization, people are living close to the substations or the city premises. So the reduction of the noise levels can be achieved as well to meet the local regulations while avoiding any external kind of sound barriers. So this is possible through Hitachi Energy's, the engineering simulations and measurement methods and tools. When we talk about protecting ecosystem, so one of the main aspects of transformer is that the mineral oil leakages that are the major avoidable risk for environmental impact to protecting the ecosystem. So nowadays there are alternative solution fluids available, that is ester oil. These fluids are biodegradable in nature, up to 98% when it comes to their natural ester form. Natural ester form, yeah. With this esters, the main advantage is that the flash point, which is more than 300 degrees. Hence, the fire risk is avoidable. When we talk about the benefits of esters, there are some technical challenges as well because of the due to its internal properties like high viscosity, oxidation stability, then the dielectric and storage challenges as compared to mineral oils. But these are easy to address, by special design consideration. And in Hitachi Energy, we have supplied transformers with these ester oils. Again, as I mentioned, with utilization of ester fluids, which can be biodegradable in nature and environment friendly, there are some special design criteria is required. So when we talk about the criteria, the dielectric and thermal designs, then ensuring compatibility of all materials used, which means, most of the materials used in the transformers are compatible with ester fluids like copper, steel, aluminum, etc. However, some rubbers that may not be compatible with some of these ester fluids. The natural ester fluids exhibit poor stability to oxidation, so high viscosity ester oils compared to mineral oils. So these are the main design criteria which we need to consider when we talk about ester fluids using in the transformers. Also, as my colleagues Saeed were talking about this life cycle assessment, we do have such softwares to process the environmental impact in transformers as well. This life cycle assessment is a comprehensive and scientific process that quantifies the environmental impact or product or system, which is measured in tons of CO2 equivalent throughout the life cycle from the raw material acquisition to production, use, and disposal. We are referring to various ISO standards for the life cycle assessment, and we can also prepare the reports, and if it is required on demand, we can submit third-party approved reports as well. So my last slide, which is, how, when we talk about the sustainability journey, how we can support your sustainability journey, and we have set of comprehensive tools for that. So we have soon going to launch one tool, which is TCO calculator, where you can compare the transformer's energy losses, CO2 emission, payback time, and the impact of existing or future carbon cost on your economic evaluation for new transformers. And the other one, in-house life cycle assessment tools to help you to make sustainable decisions and understand the sustainability impact of your transformer and your assets. The third one, the advanced design and simulation tools, what we are using in-house in our transformer designs. We have these design tools for optimizing your design according to the sustainability objectives and your needs. Since 2022, all of the transformers what we are manufacturing and the transformers and the components whatever we are manufacturing in our factories using CO2-free electricity. And the last one, when we talk about the operational lifetime optimization, which means the existing transformers. When it comes to transformers in operation, we have set of digital tools and services to help to maximize the life of the transformers, whether through digital condition monitoring or digital solutions of retrofit, or the lifetime extension solutions, even in the replacement. So that's about it. Thank you so much.
Yes, I think now is the time for questions. If any question, please welcome. We'll be happy to answer. That one is something definitely we can talk about that. We can with our like partners, but this is not our main core of business. Our main core of business is mainly to develop a solution SF6 free. But like recycling of SF6, there are companies who are doing now when there is an end life of the substation, any substation. GIS, I said that we have GIS substation since 1960. So some of them, they may already been in their end of lifetime. So definitely the way that you will recycle the SF6 in those substation, we can extend more or less the same here. Recycling means like what? To evacuate the gas, which is already in the GIS, and then somehow recycle it, this one. As I said, exactly the same way which we are doing with the old substation, it has to be in the same way. And this is something which we can work together with our partners, which are we have partners for those who are dealing with this gas. But maybe we can help them to develop something. But again, back to my first statement, our goal was to introduce a new gas with the low GWP to the market, to the environment, with a much lower effect on the greenhouse. This is which we are doing, yes.
Okay, I have two questions for transformers. So the first one is basically, you put a point saying that some sort of retrofit conditioning monitoring can be done. So does it cover the entire thing, like oil monitoring, as well as the tap changes, and what sort of service?
Absolutely, it covers the entire solution. As we mentioned, the tap changes and all entire solution will be covered in that condition monitoring. Yeah.
So will it be like a cloud-based online monitoring or periodic inspections?
No, it's online monitoring. The solutions are online monitoring.
and you can provide for your competitors' transformers as
Yes,
well.
absolutely. We can do that as well.
Okay, thank you.
Yes, please.
Hi. Sorry. This is on the replacing SF6 with the Iconic. So how cost effective with the SF6 and this Iconic products? And can we expect the green hydrogen filled GIS systems also from Hitachi?
You know, the second, let's first reply to the second. Second is a totally new concept. I'm not in position to talk about that one. I know about Econic, but I don't know that much about this. But about, we are talking about the cost effective. You know, we have to consider all elements of the project, the total cost life cycle, of the total life cycle cost of the project. Like the same way which we, let's say, 50, 60 years ago, when we introduced the GIS solution to the market, we said one GIS bay is maybe almost, I could say, 10 times more or maybe 7, 8 times more expensive than live tank breaker. You know, then how was that? The market, the customer, the utilities, they look at the whole cost of the project, complete cost of the project, and then they put all together, and they, for them was like a totally acceptable project. So if you compare just the one bay of the SF6 with one bay of SF6, definitely the price of this Iconic solution is higher. But if you consider all other elements beside that, you will see that I showed in the reference list. Sooner or later, the customers, the utilities, the governments, they will go to this direction.
Thank you.
You're welcome.
Actually, in addition to the cost that I wanted also to ask about is partial discharge resistance, some comparison regarding the contamination, sensitivity, aging, chemical strength, thermal strength, some comparison between the SF6 and those gases.
If you remember in my presentation, I talked about we are moving on the same concept of puffers and arc extinguishing, and then the idea was to find a gas to have the same characteristics, the same way which we have SF6. So the solution which we have introduced the market is fully compatible to the old solution, and on top of that, which is very important, is the eco-friendly. So it's like a neutral carbon-free or something, a neutral carbon-free solution. So as I could say in one sentence, yes, it's fully compatible, and it has all the characteristics which we had in SF6 also is implemented here. The same